So today I'm going to talk a little bit of Nowcaster, which is a package, our package that me and Leonardo will build during my stage, my part-time job on São Paulo State Center for Surveillance. And the package is basically like a thing that I built there to help colleagues and myself to work on day-to-day decision make, like having a good nowcasting algorithm there to understand and like to have better insights on the epidemic curve, most on SARS-CoV-2 hospitalizations. And basically this is it. So a little bit of us. I'm a physicist by background, but I'm moving to epidemiology since the beginning of my PhD. So nowadays I'm an associate postdoctoral research here at Yale. And I'm working with trying to integrate sequence data with epidemiological data and to produce new methods of nowcasting on cases, mostly on SARS-CoV-2 variants. Leonardo Bastos, as he said, and I didn't heard because my internet has just failed, is associate researcher at Fiocruz, which is like, it's a research institution in Brazil dedicated to public health and epidemiology, but like in a pretty broad range. And this is it. These are our GitHubs, our emails, and our Twitter. We were pretty active on Twitter, but Twitter is just like disappearing. So probably we're gonna move to Mastodon sometime. So this is it, a little bit of backgrounds and things that happens behind the building of the package or during the building of the package. So the package was developed between me and Leonardo, and we just met each other during our presence and collaboration on Observatório Covid-19 BR, which is just like, it's a voluntary scientific insights communication initiative to inform the public health about the pandemic in Brazil. We are scientists of a numerous backgrounds, like epidemiologists, but like physicists, mathematicians, biologists, policy scientists, political scientists, social scientists, and journalists, and things like this. And we have this amazing website, which is not updated nowadays, but will be soon. And that we produce some nowcast estimates for all 27 states of Brazil and for all 27 state capitals in Brazil and some other selected cities. So if you're gonna visit it, it will be pretty nice. A little bit of the notification process in Brazil, which is a little bit complicated and complex. Brazil has many systems for mandatory notification of very different infectious disease, and like dengue, chikungunya, Zika, HIV, malaria, tuberculosis, and so on. And Brazil has some other systems that monitor and survey some syndromic grievances like severe acute respiratory illness, pediatric multisystemic inflammatory syndrome, influenza-like illness, and things like this. As well, we have notification systems for chronic disease as cancer, diabetes, and things like this. One thing that it's not clear for everyone and the people in general, but probably for most of you here, it's totally clear is that any notification system has delays. This is caused by the notification process itself sometimes, but it can be caused by the natural history of disease. Like vector-borne disease takes some time on the vector, and this can produce some delays between the person that was bitten by a mosquito, infected this mosquito, for example. This mosquito takes some time to become infectious and take another some time to beat another person. This person that got infected by these mosquitoes, this mosquito takes some time to become infected and to onset their symptoms. So this is it. This is why delays exist and why it happens. And basically, my definition of nowcasting is the procedure of estimating happening on counts. Like we are interested in estimating case hospitalizations and deaths counts that were not yet notified, like they are not present on the notification system, but they are happening now. So this is my definition of nowcasting. Any algorithm or any model that you can estimate these counts is a nowcasting to me. So in summary, can be said that it's short-term database forecasting. So one thing that it's good to visualize is the natural history of any infectious disease. That it's like basically any infectious disease has 3 dates, which is the first one is infection day or infection date, which is normally normally is not accessible to anyone because it's hard to determine when you become infected or where it is the infection event. The first date that it's like apparent and can be visualized or that we have information on it, it's the date of onset of first symptoms. And this is basically the basic epidemiological date. And after it, there is a date for the reporting of this case on a database or notification system, which it can be the notification date itself, but sometimes can be any other date, like the date that the case are not announced that it's notified. It's something different, but it's similar, but it's something different. This happens in Brazilian's notification systems all the times. And just having 2 dates for a case is misleading. It's misleading on any basis.
Just to break in quickly.
I think there's
a question from Adrian.
Yeah, so is it fine for you if we just ask short questions in between?
No, it's okay. It's okay. Go on.
Yeah, I was just interested because you mentioned the vector-borne diseases before.
Yeah.
So, and how would the delays from this vector-based transmission play in here? This is something I didn't fully understand because I thought as long as you're basically just tracking infected people, the vector-borne transmission will only lead to differences in the generation time. But how does that affect the notification delays?
Probably you are correct on this. There are some generation time on mosquito. These may be not counted on the date of onset of first symptoms, and the epidemics, for example, dengue epidemics has its space more linked to the. Okay, we can measure it on any date, but to me, it's more linked to the day that mosquito life cycle. So the epidemics, if we look at epidemics like dengue epidemics on the notification date, for example, we are totally late on the onset of first symptoms date. This is sometimes that happens on Brazil, but we have to consider that there are sometimes that this date of onset of first symptoms are delayed by this process of the virus going to the mosquito, turning the mosquito on an infectious agent, spread the epidemic. So there are some methods that you can try to use to correct or to guess these supposed dates which happens before the date of onset of first symptoms. Like this can be done with back projection because it's a guess date. So sometime between here, like before the infection date, we have the mosquito cycle, and we can guess the infection date. Is that clear, Adrian?
Yeah, I think I get your point now. So probably what you're saying is that the mosquito infection cycle is also an important part of the transmission, and ideally, if we wanted to track transmission in real time, we would also have to follow that. But it's probably difficult in practice. But now I get what you mean. Why this is also part of the delays.
Yeah. This can affect delays too. This is what my message was there.
But he's correct because it doesn't affect the nowcasts itself. Because
we're
actually looking at the onset and the reporting day, so it doesn't matter if there is a mosquito involved or not. It's just it's part of the natural history of the disease. So that's why Rafa is talking about. So
this is true. Yeah, sometimes we have to consider it. Sometimes we just ignore it. Okay, can I go on? So basically, there are two techniques at least to me, that we can correct the date of onset of first symptoms or the notification date. To correct the delays between the date of onset of first symptoms to notification date, we are doing nowcasting. And to correct the delays between infection date and the date of onset of first symptoms, we are doing back projection. They are different in nature because, like, infection dates are things that we have to guess. We don't have the date itself. And so basically we have to spread the date of onset of first symptoms over a distribution of generation times. And nowcasting is like we have both of dates, and we can measure the delay between those dates, and from it we can correct the delay on the date of onset of first symptoms. So this is it. We have like different type of access to those dates, and it's important to consider that all infectious disease has these three types of dates at least. For example, one thing that happens on HIV is that HIV has a long latent period. So it takes like years to an infected person has its date of onset of first symptoms. And probably when this person is notified, it's like years ahead of the date of onset of first symptoms. So if we count, for example, on this example on HIV, if we count cases by any of those dates, we are totally delayed. Like we are missing many cases that are being generated or were being generated like years before it. And this is a pretty problematic on controlling the spread of the disease. So this has to be taken account on estimating new cases of it. So basically my message here in this part is like delays are misleading, and they are present and everywhere at every single notification system. And for unaware people, this is totally missing, and then this can have huge impacts on policy making and decision making. Like we saw it, like this is a story from the beginning of the pandemic. Like we were in this part of case counts, like on April 2020, and I was producing some nowcastings on deaths by SARS-CoV-2 in Brazil. And I was just saying that like on the present week, we have like 3,000 deaths. And a journalist calls me at midnight and she said like she was accusing me like to lying to the public debate, because she was not seeing those deaths on the register. And I have to explain her what is nowcasting and why it's for. And basically we nowadays, like in the last week, Brazil just has reached 700,000 deaths by SARS-CoV-2. So this is why delays can be totally misleading. Okay. And my message here is like, we have to acknowledge that we have delays on systems. So after it, we can like do anything or have better insights on it. So basically, as Sam said on our talk before I start presenting, our approach to correct delays is the chain ladder model from Kramer. Leonardo is more specialist on this than me. But basically, those are models that are being used on actuarial sciences since 1980s. And the basic idea is that we can correct delays, looking to the distribution of delays over how many days we have on average of delays for each type of data that we are trying to nowcasting. The application of this type of models or any kind of models on nowcasting, it's not new too on infectious disease. Like, as I said, the HIV epidemic has posed that challenging on notification real-time estimations of the incidence. And as I said again, it has like a long latent phase. Like after a person got infected, it can be delayed for 10 years to the process of infection, the onset of infections. And this person to become aware of its disease, it takes like more time, and to this person that it's infected and have the disease, to go to a notification, to go to a hospital and looking for help and treatment, it takes an even bigger time to become an effective case on the notification system. This contributes to many problems that can spread the disease even more, like spreading of the disease. And then this can be misleading on planning policies to mitigate, treat, and stop the outbreaks. So this is one of the first models. This is a typo, the parentheses should be here. This is a first model to correct infectious estimates of cases on HIV. And just basically there is a typo 2 here. We suppose that the count of cases diagnosed at this time is modeled by a Poisson, and the mean of this Poisson distribution is given by these two covariates. And basically, our approach here is more a Bayesian version of these nowcasting models. And our approach on Nowcaster is through a negative binomial. We propose Leonardo basically proposed a negative binomial distribution to correct the notification of the delays in dengue seasonal epidemics in Brazil. And the model was like this. So the counts of dengue on the season at the time T with delay D has a negative binomial form. And given by this lambda and by this phi. And lambda it has its covariates like this, and with me and alpha, beta, and gamma. There is another approach on Bayesian framework to correct and to nowcasting data. One of it is this one that we use on the beginning of our website, Observatório Covid-19, which is more a Poisson model. We propose it to correct the delays. And it basically has this work. A little bit of the language of chain ladder models and delay triangle. So this is the model proposed by Leonardo and collaborators on 2019, which is the model as I just showed before. The model proposed like a random effect on alpha t to capture the mean temporal evolution of the count terminating process. A beta d for the delays to capture the mean structure of the delays mechanism. And the last term is a time delay interaction. So as the time passes on the epidemics, the delays can vary too. And the basic idea here is like we are counting how many cases we have with zero delay at time 1, with one day or 1 week of delay at time 1, 2, and so on. So this blue part of the delay triangle is basically the observations, and this gray part of the delay triangle, it's the partially observed cases. So when we correct when we estimate this part, we are producing nowcasting. All of these red part are totally unobserved data, and when we produce some estimates over it, we are producing forecasting. So this is it. This is the basic idea behind the model that we employed on Nowcaster. So a little bit of Nowcaster package itself. It was born, as I said on the beginning of the talk, it was born during my period on the state of São Paulo CDC. And that I noticed that many of my colleagues had like to estimate the now happening counts for any different kind of disease. So my idea was to produce a simple model that can nowcasting the delay between the date of onset of first symptoms and date of notifications. Because we had like demands all days to just give some estimate on nowadays counts of any type of disease. I work placed on respiratory disease notification, division of respiratory disease notifications. And this is it. I saw it like many times colleagues of mine having trouble because on the last week they give like an estimate, or they just count the case of measles outbreaks, and a week after the outbreak grows like hundreds of cases, and the policymaker and the politicians were like discussing that we were giving misleading data, but this is not the case. Like we're just giving the data. At least my colleagues they were just giving the data that they have on its hands on that time. So this is why I built the package. And basically the package is a wrapper around all of the models that Leonardo have developed for dengue disease, and that we were using to nowcasting SARS-CoV-2 hospitalizations in Brazil. And this is it. so my idea was to build this package to have a simple tool that is fast and good in one thing, that it's estimating the delay due to notification. Another concept that I put on the package, it's like to have one function that does everything, and this function is mainly directed to CVAP, which is the notification database for SARS-CoV. For actually it's the notification database for severe acute respiratory illnesses in Brazil. But CVAP gripe was captured the majority of hospitalization due to SARS-CoV-2, and many of different modifier algorithm that it's run behind the Nowcaster package. It's employed and in use on InfoGripe, which is basically the alert system of CVAP gripe. InfoDengue, the model was built originally for this alert system, and like nowadays we are using people on São Paulo State CDC are using for any other different, like for nowcasting influenza-like illnesses and things like this. So Nowcaster makes use of INLA, which is a probabilistic programming language that it's not on CRAN. This is a first difficult on using Nowcaster, but it's totally overcome if you run this first line, which is just installing INLA on your notebook or PC. And inline stands for integrated nest Laplace approximation, which is I'm gain for Bayesian inference. One thing that I have to say that INLA is faster than traditional methods for Bayesian inference like MC, and HMC. For us, that we were dealing like with, as I said, Brazil has reached like last week 700,000 deaths by SARS-CoV-2, but our hospitalization database was like over, nowadays it's probably over 3 million registered. So we have to count the delays between date of onset of first symptoms and date of notification for every single of these cases to have a good estimate for the whole Brazil, or if we have like a state as like São Paulo, which it has like a population of 44 million inhabitants. As I remember, the CVAP from São Paulo, the database for SARS-CoV-2 hospitalization in São Paulo state has like probably 2 million entries. And this is why Nowcaster is good on helping us with these big data issues.
Can I just jump in, sorry? And
go on.
You're using an aggregate count likelihood, right? So does the size of the data, is the size of the data really a reason to need to use something like Nowcaster? Wouldn't the reason
it's individual
be...
level. It's individual
yeah,
level.
Yeah, but aren't you aggregating the models has Poisson likelihood or net binomial likelihood?
Yeah, but for calculating the delay, you need to use the individual level.
So you're calculating the data as an initial step before you put it into the model?
Yeah.
Okay, cool. Excellent. Thanks.
Okay.
But you're correct.
And sorry, in that model, you're also using INLA because you could use...
You're correct. The method doesn't require individual level data, aggregated data. But the package uses individual level data because it's developed for people using in the people who have access to individual level data.
Yeah, this is it.
The real advantage, right, for you guys is that you can fit over many more spatial kind of aggregations because it learns very fast because of the approximation.
Yep.
Regardless of the number of counts per like Strata.
Yeah. Thanks, Sam. So the package itself has two basic models. One is a non-age dependent model, which doesn't suppose delays are hierarchically distributed. Sorry, on the contrary, it supposes that delays are hierarchically distributed by age classes. And the other one is an age-dependent model, which stratifies the delays by age classes. So the first model is basically like this. It's a modification from the 2019 model for dengue seasonality nowcasting. We have count of cases by time t, delay t, and it's given by a negative binomial that it's parameterized through this lambda. And this lambda, it's fitted like this. Alpha is a Gaussian distribution with a very large variance. Beta t it follows a second order handle with precision tau beta, and gamma d follows a first order handle with precision tau gamma. And this is like the usage of the functions on the package. So the package comes with a lazy data set, which is SARS-CoV-2 hospitalizations at the city of Belo Horizonte. And the usage is basic like this. So you employ the data set to the function through data set parameter. Date of onset, like it's employed with this parameter, date of onset and date of report. And this is just a flag to return the data weekly. And the package returns to you this estimate. So it returns IC over the mean. And basically this is the usage. The other model that's employed on the package is a age-dependent model. So we suppose that we have a negative binomial distribution for counts of cases at time d with delay d and at the age class A. And we do this like the same as before, but by age classes. So we stratify each of the cases on any type of age classes. One thing that I have made to work with my colleagues there on São Paulo State CDC was to break the data on these age classes automatically behind the package. So again, it's pretty much the same function, nowcasting minla, with this lazy data set, drag BH. We just pass the column for date of onset of first symptoms, the column for date of notification. In our case, it's date of digitation. Like this is a date that it's after the notification because the case has entered to the base, but was not input on the base. So the digitation data, it's the latest data that we have on databases, on CVAP grip databases system, which is a particularity of Brazil. We have this kind of type of delays and informations on our notification systems. Again, the data by week flag and beans age, it's in which bins of ages you want the data to be split. And age call is the column of age that it's given on the data set. And this is we can stratify the estimates through age classes, but this here to show the difference that we have between this IC and this IC on using the age-dependent model. This is a learning from the pandemics. We learned that delays differ on each age class. The basic explanation for it, it's like the pediatric cases are less prone to delays. This is basically because Brazil has these notification systems that are national, but the way that the data for pediatric cases are imputed on these systems is different from adult cases. So this is a learning from the data, and this is a learning from the pandemic, and this is it. This is why we have built Nowcaster based on these two models. Before finishing, I have to say that we have different versions of this model employed on InfoGripe. As I said, InfoGripe is a monitoring system for the severe acute respiratory illness records in Brazil. It's a system that was built for the pandemic of SARS-CoV-1, and as we saw during the pandemic, it is a good system to capture the hospitalizations of SARS-CoV-2. As Leo said, the Civet Gripe pairs the individual level data for each of the hospitalizations in Brazil due to SARS-CoV-2 or any severe acute respiratory illness. InfoDengue, as I said, is the beginning of all this. So the first model that Leonardo has developed that was for nowcasting dengue-like illness notifications. And as I said, nowadays, the package is routinely used on CDC, São Paulo State CDC. There they are using for nowcasting notifications of SARI on state level, influenza-like illness. We just with the package we were able to capture a growth on RSV pediatric hospitalization records. Again, with the package being employed on São Paulo State CDC, we just capture outbreak of measles records in São Paulo City, and this is it. My takeaways on this process of building a package during the pandemic and building a package that can be used by people that are not totally aware of misleading of delays is like this. Delays are everywhere on every single system. So is the first step to me, it's like we have to acknowledge this and be aware of them. After it, we can produce new insight from the data. This is a message more to me than to anyone. It's the first time that I use one of these nowcasting models. It was really hard to explain to my colleagues that were not used to being using R and doing nowcasting what I've done. So keep it simple, keep it open and easy to use. This is good because this is easy. This can percolate on the policymakers and decision makers and government staff, because they can understand better what is happening, and so they can help you on these insights or on defending these decisions that has to be taken. They are these people that, like policymakers and decision makers and government staff, they are on daily huge pressure to take impacting decisions on short time. So an effective way that I've learned during the pandemic is to communicate anything that you are doing in a simple manner, like not a simplistic manner, but a simple manner. Like we have these cases now today that we are observing, but these cases has delays. And after we run on a model, we have this another estimate, which is totally different from the data that we are seeing nowadays. This is another thing that I'm not keeping nowadays, because I just moved to USA, so my life is I'm starting to adapting here. But this is it, always updating and always discussing the results. The Observatory COVID-19 was one of these places that we can discuss it, and the package basically just born there, because me and Leonardo was discussing all the times and weekly or even daily basis the pace of pandemics and the nowcasting estimates that we were producing for the whole Brazil. So this is it, always updating and always discussing the results. This makes people to engage on the problem. This grows a community over it, and more than solving the problem or coming with a solution or new insights on it, communities is a good thing to build on these times of challenging things like the pandemic itself. Some acknowledgements to InfoGrip and to InfoDengue, which are one of the nicest alert system that we have in Brazil. To FieldTech, which has funded the creation of the package through a fellowship to me, and to our public health system that it's capturing and maintaining those systems that we can use to generate estimates on it. A special thanks to CVE, which is the São Paulo State CDC, that gave me space and opportunity to develop this package. This is it.
Yeah, thank you. That was really interesting, really great. Yeah, if everyone can just have a little round of applause. Yang, can we have some applause, please?
Yeah.
Yeah. Okay. Clearly not. Not really. Awesome. So I guess questions. I have like an A4 page of questions. But I will let some other people jump in first.
Okay.
If you just want to put your hand up, and then I will control the questioning. That sounds reasonable. I will put my own hand up. Okay. While people warm up, I'm going to jump in with a question. So my first question is, at the beginning, you said the aim is to make a package that's easy and user-friendly to use. One, who do you see as your users? And two, how do you define and test that your package is easy to use? Because these are things I struggle with. Sorry.
So it just cut a little bit my audio. Can you repeat the questions?
Sorry. So what I said was, at the beginning, you said you wanted to make a tool that was easy to use and user-friendly. And so there's a couple of like things to unpack there. One is, there are other tools. Were they not user-friendly? How do you define user-friendly? Who are your users? And then how did you test that you'd achieved your goal of being user-friendly?
Yeah, this is it. Okay. The idea of user-friendly is like a localized thing. It was just as I said, like I saw colleagues all the times every week having discussions on that the data they were seeing at raw were not informing them the real situation. So I decided to build the functions around the specificities of CBAP grippy. So maybe I biased here on saying that it's user friendly, but it's like it's user friendly for my colleagues that use CBAP grippy and systems that are similar to Brazilian systems. When we have like a notification database that has columns for data of onset of first symptoms and data of notification. So just basically give the raw data to the function. on this format, and it give you estimates. I agree that I don't have a broad user experience test on the package. This is good to know that we have to have more generalization on the functions and things like this. So this is good to know. Thank you for acknowledging to me, Sam. This is totally true. I'm totally biased on this. And the second question was?
They were all just a complicated version of the same question. The second question is, so like, who is your user, which you've kind of already answered, and then how do you know they liked it? And I guess it sounds like you know they liked it by asking them, which is cool. But my follow-up to that would be, one, are they using it in the sense that they're just running a model that you have specified or that someone who developed the package has specified, or are they able to kind of manipulate it for their own aims? And then also, if you want to move to be a more general package, so say some of the people on this call, for example, might want to use it, is that something you're interested in? And do you think you're going to have to make design changes, or the designs you've already like built in are going to be, you know, nice and extensible?
I'm totally interested on moving to more generalized package. Like, if anyone has used Nowcaster and has come up with issues, please submit a pull request on our GitHub. I'm totally open to build a more generalized package. I think this is as many tools as we can have, it's better. The users they cannot change the model itself. They basically choose between the age dependent or the non-age dependent model. Leonardo and we discussed how can we do this, but still using INLA. We don't know how can we do this. In summary. But basically, this is the idea. This is why the package doesn't have like a model that it can be employed, it can be imputed by the user, because the usage of the package were firstly on users that are not educated on modeling, so they need to give some estimates, nowcasting estimates, but they don't have like a good background on modeling, on statistical modeling. So this is why at the first attempt, we have built a package that has this non-flexible way to model. I don't know. Me and Leonardo, we are planning to at least to employ the spatial version or in the spatial time version of models described on his paper of 2019. This is pretty good on, basically it's this, like, the package is pretty good on databases that are similar to Brazilian notification system. But I'm totally open to move to a more generalist package. This is it.
Yeah, I'm just adding something, like, because well, we have some contacts on the people working on epidemiologic surveillance in the government. And they keep asking us to either run the estimates, because, well, they used to ignore the last 4 weeks because they know about the delay, so they just ignore it. But they want to have a fast answer. And, well, they didn't know how to do it, so they ask us to do it. And then, well, I don't want to do it. So I start giving them my scripts, which are rubbish. Well, my scripts work, but it's something that, well, someone needs to run all the things. So actually, Rafa get the script and transform it into a package. And then that's the history, actually. We didn't think about building a package properly or anything like that. We just, well, people need it, so let's just give to them what they need, and that's it. and leave me alone, something like that, you know?
Yeah, it's more than this. Like, I just moved out from Brazil, so if anyone needs to run a script that it's like in São Paulo State CDC, I cannot go there and run from them. So they have to be able to do some nowcasting estimates by themselves, using what we've done with the package. It's easier for them. This is basically the answer for all.
That makes
all
sense. I'm gonna cut you off now. That was a long answer and a very long question. And everyone else wants to ask questions. Adrian, please ask away.
Yeah, I don't. Which one should I ask? I definitely understand that inlay is quite fast compared to MCMC, but I have to admit I haven't used Nowcaster myself. So can you just roughly say like what runtimes you typically have on the data sets? Just roughly like just roughly how long it usually takes for the applications you're running this.
How much time for me to like, I was on the beginning of 2022, I was running nowcasting for the São Paulo State estimates on daily basis, and it runs over a database with like over 3 million entries on like 1 hour on PCs that are pretty old.
How many? I'm not quite understanding why the count size is super relevant. How many strata and how many time points would that be? I think that would be the most comparable to our issues.
Yeah.
I think about 10 straight age groups, and probably for different municipalities, which I'm not sure how many there are in São Paulo, but a single run is a couple of seconds.
Yeah.
So I think that is the question. That a single run like that example that is in the package is just a couple of seconds.
Yeah, but in a more complex model, we have 10 age groups, say, and we might be spatially on 20 locations, maybe, and you fitting to something like 100 time points. Do you just have some impression of what that complexity is?
It's more than
that's where the real scaling benefit, like simple models take a couple of seconds in MCMC as well, right? So like the really complicated models where the scaling is really nice.
Yeah.
Yeah.
Well, comparing to MCMC is like about, 20 times faster.
Yeah, it's kind of like it. Yeah.
We tried
that.
50 times faster.
Yeah, I can say that our base of comparison is like we just used the package from McAfee, which is probably based on Stan. I don't know. I don't remember.
It's based on JAGs.
Oh, it's based on JAGs. Yeah, this is true.
It's going to be pretty slow.
Yeah, pretty slow. Like when we switch it from using knobs to Nowcaster on São Paulo State, it cuts like it was less than 20 times, but it was more than 10 times faster. Because I remember that. Yeah, I remember on the beginning of Omicron wave, when I was in the São Paulo State CDC, the first tries that I have done was using knobs, which use JAGs. And I come to Leonardo and said to him that, Leo, please give me your codes that I will make a package on it, because it's taking like my whole day to run a nowcasting for 17 regions of the state of São Paulo, which is not so much.
Maybe you got it to run in the first place. I think I couldn't get it to run when I tried. It'd be really interesting to know, to compare to some of the stuff that we've been doing recently, to see what the time difference is, because it's so attractive. Having like fast, people love fast, and I think fast has got a real quality to it, even if there's some approximation sacrifice. On that, just to follow on, have you looked at the quality of the approximation? Because obviously, it is an approximation. It's pretty good in quite a lot of circumstances. Is it generally good here?
Yeah.
Yeah.
We compare that to some MCMCs and also some backcast to see what happened. Well, doing some kind of doing some Nowcast with place which we know and compare with the MCMC and NULA. We did that. Not well. We did that for a couple of examples. I think it should be do a systematic. Analysis, but we didn't. We just run a couple of places, and in all of places we run, it was okay.
Yeah, that makes sense. Is that in the documentation somewhere? That's the sort of thing that I always, when I'm like directing people to tools, it's nice to see because it's like
probably it is. I'm not sure if I don't think in the package because we didn't implement any MCMC there, so just did it. I think it's in the paper. I think.
Okay, that makes sense. I have some other questions. Adrian, you can jump back in. Anyone else who has a question, feel very free to launch into it. There are no silly questions. Well, there are silly questions, but as long as they're relatively on point.
So in the beginning, you mentioned this whole delay timeline with timing into infection, and then you mentioned this part which I think that's not really covered in Nowcaster, like this back projection. But I was interested. So the users that have been using Nowcaster, did they do some further downstream stuff with this? Or did they really just look at the Nowcasted symptom onset time series? Did they try, for example, to compute reproduction numbers or growth rates, things like this afterwards?
I'm not aware of any users doing this, but I have done this for São Paulo again, and some capitals in Brazil. I will stop.
We are doing that for dengue. We are doing that for dengue.
Yeah, you are doing right, Leo. I have done this for SARS-CoV-2 cases on some state capitals. I have these, like, it's unpublished yet, but things. Oh, I don't have it open.
Yeah, that's no problem. But maybe just as a follow-up, can you just roughly describe what you did in such a case, like how you used the nowcasting results, just like on the technical level for the downstream analysis?
Yeah, well, we are actually doing we are getting the Nowcast output, which is basically several time series. So we are using it to propagate uncertainty. So we run the model, 100 times, and then we propagate the uncertainty to calculate the RT intervals or anything.
So you're doing that by you get the nowcast, you get posterior, you get posterior samples, and then whatever downstream analysis you're doing. So it sounds a bit like maybe I'm going to take a wild punt, epiestim, something like that. When you do that, you run that model multiple times, once each on each posterior sample.
Yeah, exactly.
And that
like
way,
a Monte Carlo.
Yeah. And have you looked at? All right. The reason we're asking so many questions about this is because Adrian is looking at comparing stepwise, he's doing it all in a pipeline. So it's quite interesting.
Nice.
Yeah, sorry, Adrian. I don't know if that's a secret. And yeah, have you looked at how many samples? Because you get this really nice benefit. Like, inland's really fast. That's nice. My impression is it's quite hard to extend to have a more complex genetic process. And so your cost is you can't then add more kind of like upstream mechanism. And so you need to do this multi-stage thing.
Yeah.
Have you looked at, is 100 samples enough to get enough of the posterior for the RT step or back here?
We are doing 1,000, but
1,000.
I said I don't know why I said 100.
Fair enough. And is that with an additional deconvolution step in the middle as well? Or is that straight?
No,
RT
I think it's straight. Yeah, I think straight.
So it's just applying on the symptom onsets, right?
Yeah. Yeah. And then the other method that does the backcast is not the nowcast method. So kind of. Yeah. So if I'm calculating the RT, so someone estimate the infection date, depend on the disease, probably dengue. So they just do some deconvolution or something like that. But it's not on the Nowcast. So we are using the trajectories forecast, well, estimated in the Nowcast, go back to the other method and imputate it there, but then we do that 1,000 times and we get...
You are doing this for dengue, right? Well,
yeah.
We have tried this. This is basically the same thing that Leo has said. Itself doesn't have this algorithm for back projection. We have done this for to have better or like to have more RT estimates for COP2 in some capitals of Brazil, and it's basically we are using, I don't remember the algorithm, is expectation maximization.
The one from the 1990s, Richardson Layson paper that
that's the one,
Yeah, but we didn't finish this paper yet. It's like 3 years writing paper, so.
Yeah, that sounds really interesting. I'd be interested to know what the performance of that is like. And yeah, I guess a related question, and I kind of already asked it, is my understanding of how INLA works is that you can't really make kind of customized models in the sense of like other PPLs. So you're quite restricted to kind of like regression like models. Is that right? And have you thought a bit about how you could maybe push it to get more mechanism in the model? So maybe some sort of mechanism for a renewal equation, so you could do it all in model, maybe some sort of mechanism for deconvolution in model. Is that just not possible, or is it very hard, or is it actually easier than I think it is?
Well, INLA works for a class of models that is relatively limited. But the thing is, well, the people working on INLA development, they're really workaholics. So just if you ask them to do it, they do it. It's really crazy. So if it can be done, in INLA, those guys make it work. That's how my experience working with them. But I'm not sure if it's possible. So if it's possible, it can be done. It's basically the method is basically an approximation that change the integrals to summations and make some very clever stuff. And but it's really restrictive to latent Gaussian models, which is basically
I there's TNT template builder, right? Which also works on the Laplace approximation and is more flexible, but doesn't, I gather, come with all the tools that you get kind of in the INLA package, and therefore you'd lose the nice kind of like formula specification and all the spatial stuff.
So exactly. For this package, I wanted to get rid of INLA. Like I went to get the things just for that model. Then it'd be a way faster. Well, a way easier to other people to use it because, well, if I want a guy to install the INLA in that computer, like, well, it's like a bazooka to kill mosquito, like, well.
I mean, that's exactly the same problem we have with Stan. So
So for Stan, it's the same. So you need to install in Stan and all the stuff, but then you just need to tiny bit of it.
Yeah, that makes a lot of sense. Okay, I have one more question, and then perhaps we should wrap up because we've gone on quite a long time. Does anyone else have another question before I ask this? Adrian, okay. Is it okay if we have two more questions and then we'll wrap up?
Yeah, but I think I can ask mine at the end because it's a very closing thing. So you can go.
Wow, what a big deal.
So you mentioned Oliver Stone. Alba is working with him in
It's nice to meet you, Alba. I knew you were coming because Oliver emailed me.
I know she can call. I know she can say anything, but she's working.
So what I was going to ask is, have you considered some more external validation of your method? And if so, how? And what do you think is most interesting to look at? So that the kind of examples that come to mind is like Johannes, who was on the calls earlier. His Nowcasting hub was quite a nice way of comparing across models, but only looked at kind of like out of sample performance. And he's also running a new one now in Germany for influenza. I just wonder what your thoughts are about that, and if you've had any struggles, because it's also, I found it when developing these sort of methods, it's hugely time intensive to do that sort of validation. So everyone's like, have you done any validation? And the answer is yeah, a bit, but also not as much as I'd like to usually.
Well, do you want to answer that, Rafa?
Sure. We don't have done any base of comparison that it's like open, because this is it. We are trying to finish the paper and publish it something and say, okay, we have this. But we are totally open to do this type of comparison. It's I really wanna see other methods and what they can produce, or if they can help a little bit on Nowcaster, or we can help a little bit on this community of Nowcasting. I think this is totally important on it, like to have different tools with different levels of imputing information that you can give to the models and to the tools. It's as I said all the time of my talk, that there are some people that they are taking some important decisions. Sometimes they have this knowledge. I know some ones that are pretty good on statistical modeling and inference, but the majority is not. It's like they need to have tools that are open, that are good on they are doing, and that help them. But I'm totally open. We can try. We can chat about it, and I don't know, try any collaboration on it.
That'd be super interesting, because particularly, so not to advertise artwork, because that's very boring, but artwork where you can do hierarchical, so spatial, age stratified, blah blah blah. It might be interesting to compare to, because I don't think there are many others that can, but because ours is full MCMC, it's really slow, and so you'll look really good. I would imagine, which would be cool. I think that'd be interesting to talk about. There might be some downsides to your stuff, but I can't see what they are. So
No, I would be very happy to see very different approaches, because we are using it in a real time, early warning real time for dengue, and we run the model for all cities in Brazil, which are 5,500. And we do that weekly, so it's really expensive to do. So we did some cheap model. Well, if you have a spatial temporal model that runs, well, if it takes a day, it would be fine. But we need to do, if it improve reduce the intervals, and we can do some, I don't know, 4-week forecasts, or not long, short-term forecasts. And if we can do that, we can happily change that for a model here. So, but we are actually providing the Minister of Health the output for, there is an outbreak there based on our estimate. So we are doing that, and we are running using this very simple model that Rafa presents. We are not even using the spatial ones or the cool ones. We are not doing that, and it's just because they're slow.
And that makes a lot of sense.
But I would be really happy. Like for instance, Alba is doing some really cool MCMC model for modeling COVID under the SARI data. So it's really cool. But I don't know if we are going to be able to implement that in our system here, in the other system that we have. But maybe we can. I don't know if they manage to do something fast, or maybe feasible, like something that runs in one night or something like that.
I think that's a good point about runtimes. Often runtimes, it needs to take the amount of time you have, but it can take up to that amount of time. So like it can be taken 1 second, but also if you have like 6 hours for decision, it can take 6 hours. It's less optimal, but it can. I think it's a good point.
Yeah.
This is it. Another thing to add on this, on like trying to compare and try to build another tools, it's that at this moment, this like the Minister of Health is contacting Leonardo all the time, or weekly, like how it's dengue nowadays in Brazil. They are open to this, and I think this is an opportunity to us,
especially now change the government.
Yeah. No, but I'm saying on global scale, like the US are open to build those systems or to build those tools. The UK are open to use all these tools and all these models. So it's a good timing, and it's good to have comparisons and good to have like improvements on each of these tools. So.
Yeah, I agree. I put some more comments in the chat, but I won't say anything more. Adrian, do you want to ask your last question? Then we can wrap up.
Yeah, I was actually
we're attrition to just the speakers.
Yeah. So in half, it's also a question to us, or like to you, Sam. Are we mentioning, like, are we pointing to Nowcaster as an alternative package on the EP Nowcast side? And if not, should we maybe do that?
We should, and we aren't. Yeah, we should have a list of resources. We don't have one. I really wanted to. So sorry, this is a deeply in the weeds question. We have this like EP Nowcast community site, and then we have like some package sites, and we have the like community forum. And I really wanted the community site to have like a rolling blog with like guest posts where people present their tools, and then also have like a resources section. But no one's written it yet. But I agree, we should do that. Yeah.
And I've just seen that on the Nowcaster package site, you're already linking to some others, EP Now 2 and surveillance, which is cool. But if you want, you can maybe also add EP Nowcast as an additional tool. And we're all linking to each other.
Amazing.
Is it not there?
It's because I name packages the same thing, so it makes it impossible to tell the fact they're different.
Right.
So that is on me. Okay, awesome. I think that was really interesting. I thought it was really good, and I'd like to talk about some other stuff and talk about it some more. So I think there's a lot more to discuss. The thing that I'd be really excited about is how we can standardize inputs so that it's easier to run lots of different models. Because like a big headache with like comparing systems is that's painful.
Yeah, totally agree on it. Yeah. Sam, can you send me the comments on the chat? Because my Zoom is staggering and I'm not be able to see the chat.
Yeah, will do. Yeah, cool. Okay, I'm gonna stop.